Imagine a world without gasoline, plastics, and soap. It is really hard to think of a world without these products because they are so important in our life. All of the products are made from organic chemistry. Also, many other products are made from aldehydes, which is our main focus in this video. In this video, you will learn how to name and draw aldehydes, as well as learn about reactions involving aldehydes. An aldehyde can be shown as R bonded to C, O double bonded to C, and H bonded to C, where R is the rest of the molecule and this is the aldehyde. An aldehyde is a terminal functional group as it only occurs at the end of the carbon chain. Do not mistake aldehyde for ketones, as ketones cannot occur at the ends of the carbon chain. This is why cyclic compounds cannot have aldehyde functional groups. There is no end to the carbon chain, so an aldehyde will not form. Another way to understand this is that the carbon cannot bond with a double bonded oxygen, a hydrogen, and two more carbons, because then the central carbon will have five bonds, which is not possible. The suffix for an aldehyde is al when it has the highest precedence in the IUPAC rules, but if it has a lower precedence, the prefix is oxo. Let's take this for example. This has the highest precedence, and there are two aldehyde functional groups. These will have a lower precedence, so they will have prefixes, both oxo, because this is a ketone and this is an aldehyde. How do you determine that from the name? Because in the name, pent means that there are 5 carbons in the parent chain, and this 5 states that the oxygen will be bonded to the 5th carbon, which means it's an aldehyde because it's at the end of the carbon chain. Whereas this oxygen is bonded to the 3rd carbon, which is in the middle, which is why it's a ketone. As our first example, we will draw C7H14O. There are many ways to draw this, as this formula has many isomers. However, because we are making an aldehyde, the oxygen will be bonded to the carbon at the start of the chain. Or when it is the lower priority functional group, at the end is also a possibility. First, as there are 7 carbons in the molecular formula, we will make the parent chain 7 carbons, but the carbon chain could also be smaller, and an alkyl side group such as a methyl or ethyl group could be attached to a more central carbon, making an isomer. Let's start with the first compound that could be made using this molecular formula. First, let's draw the parent chain. So there's 7 carbons, so 1, 2, 3, 4, 5, 6, 7. And let's name this one. Not name this, number this. 1, 2, 3, 4, 5, 6, 7. Then let's double bond the oxygen to the first carbon. This oxygen could also be bonded to this carbon, as this could also be numbered 1, and then 2, 3, 4, 5, 6, 7. Now let's name this. To name this, the prefix would come from the number of carbons in the parent chain. So in this case, there are 7, so the prefix hept will be used. Number the carbon starting from the carbon with the highest priority functional group, or this one as an aldehyde functional group is attached to it. This one will stay 1 because this has the highest priority. Also, as there are no double or triple bonds in the carbons, we will use ane. But if there are, you will use ene, and you will state where the double bond is. So if there's a double bond over here, there will be 2 ene. The suffix al will be used because it is an aldehyde. The aldehyde has highest priority, and as it is a terminal functional group, it has the highest priority. It is understood that it is attached to the first carbon, which is why it does not have to be numbered. The final name would be hept in all, and the e will be taken out because the suffix starts with a vowel, so 2 vowels wouldn't make sense. So e will be taken out, and the final name would be heptanol. This is the condensed structural formula of heptanol. The complete structure could be shown as C bonded to H, double bonded to O, That's 3 bonds, so the next carbon would be single bonded to it. Two H's are single bonded to the carbon, and that repeats. Three, four, five. There'd be 2 more. 2 hydrogens are bonded to this one, and there are 3 bonded to this one. All the carbons have 4 bonds, so this is the complete formula of heptanol. Let's name another compound. First, let's number the carbons starting from the carbon with the highest priority functional group, and in this one it would be the aldehydes. So we start from here. 1, 2, 3, 4, 5. Name the lower precedence side groups in alphabetical order. So this one would be chloro, 3 chloro actually, 2 hydroxy, 4 phenyl. This one will be first because it's alphabetical order. So 3 chloro, 2 hydroxy, 4 phenyl. Okay. So after that, you will check for the number of carbons in the parent chain. So in this case, there are 5. So you will put pent. Then you will check for double or triple bonds, and in this case, there is a double bond. The third carbon. So you will put pent. 3 ene, because ene is for a double bond. And then you would, because aldehyde is the highest precedence, you will add an al suffix. So, al. And because the suffix starts with the vowel, you will take away this e, and your final name would be 3 chloro, 2 hydroxy, 4 phenyl, pent, 3 ene, al. Alcohols can be oxidized to make aldehydes by removing the H from the OH and the carbon to make a double bonded oxygen. Only first degree alcohols could make an aldehyde. Second degree alcohols will make a ketone because the carbon is connected to 2 other carbons. Aldehydes could also be oxidized to create a carboxylic acid using a very strong oxidizing reagent. Aldehydes could also go through reduction to create a first degree alcohol. A reducing agent used is platinum. Aldehydes are bonded with dipole-dipole intermolecular forces. There is no hydrogen bonding and the oxygen is more electronegative, causing dipole-dipole bonds. Weak intermolecular force means less energy would be required to break these bonds. Because of this, the boiling points of aldehydes are relatively low, but are still higher than nonpolar alkanes, alkenes, etc. Aldehydes are used in many ways. One use of an aldehyde is formaldehyde, or its IUPAC name is methanol, used to preserve biological specimen. Also, methanol is used to prepare glues, germicide, insecticides, and fungicides for plants. Acetaldehyde, or its IUPAC name ethanol, is used to create acetic acid, or IUPAC name ethanoic acid, which is also known as vinegar. However, most aldehydes are toxic and are irritants. They could cause irritation to the eyes, nose, and throat. Some foods contain aldehydes, however, such as yogurts and cheeses, but they are safe. Okay, now let's give you a try at showing your understanding about aldehydes. First, let's name this aldehyde. Please pause the video and name this compound. Okay, now I'll solve it. First, let's number the parent chain, starting from the aldehyde as it has the highest priority. Next, let's name all the side groups. So this is on the third carbon, so 3 chloro. And there's 2 methyl groups, so 2, 2 dimethyl, because there are 2. Check for double or triple bonds, but there are none in this case, so ane will be used. And since there are 4 carbons in the chain, the prefix will be but, ane. And since aldehyde has the highest priority, we will add al. And Because the suffix starts with a vowel, we will take away the e, and the final name would be 3-chloro 2,2-dimethyl butanol. Now let's give you a question on aldehyde reactions. Previously in the video stated that acetaldehyde or ethanol is used to create acetic acid or vinegar. Vinegar ethanoic acid is drawn as we have not learned how to draw it. The question is, how can ethanol be reacted to create ethanoic acid? Now let's solve this. Ethanol goes through oxidation with a strong oxidizing reagent to make ethanoic acid or vinegar. So first you would add this here to state that it's an oxidizing reagent. And the reaction type is oxidation. You would need a strong oxidizing reagent for this because usually to create an aldehyde you would use a mild oxidizing reagent from an alcohol. But to further oxidize it, you will create a carboxylic acid or vinegar. Now, at the end of this video, you should be able to determine and name an aldehyde, draw an aldehyde, know how aldehydes are formed through reactions, and how aldehydes react to form other organic compounds. You should be able to determine intermolecular forces associated with aldehydes, determine boiling points and melting points. Thank you for watching this video.